Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the concept of partial fractions and how it can be used to help you in your integration. Partial fractions is something that you came across if you took pre-calculus, and it's a way to decompose a complex fraction into what it was prior to finding that common denominator. And the way this will benefit you for integration is it'll take a hard problem and hopefully create a bunch of small, much easier problems that you can integrate separately now that they're added and subtracted. Alright, so how do we go about doing that? Well, first things first, what you have to do is be able to recognize the partial fractions. And what you'll need to do always is factor out the denominators completely. So factor denominators completely. So the steps. And then after it's factored out, you will look for one of the following scenarios, or a combination of these plausible scenarios. So, first scenario is going to be you have whatever on top and the product of linear factors on the bottom. And what you do there is you separate them with a single letter on top. However many there are. If we have a repeated root, you also put a single letter for this rule. And you put one for each repeated root. If you have a quadratic in the denominator, the power difference between the numerator and the denominator must always be 1. So we have to introduce an x in the numerator now. I'm not sure why that happened. Actually, there's no plus sign here. And that's for the next rule. And this rule here that I'm doing is a combination of these two rules here. And that's if you have a quadratic term with a repeated root. So here we would do ax plus b for the first root, cx plus d for the second root, and yx plus z, however many there are. Alright, if you know these basic scenarios, your life will be much easier. You'll be able to recognize what goes in the numerators much quicker. And my viewing window is just jumping all over the place. Okay, so after you've decomposed it into its proper rule, then the next step, well actually this would be step 3, factoring was step 1, decompose 2. Now you multiply both sides by the denominator. Left side will leave always the numerator. intact. And on the right side will be a bunch of letters times, a bunch of parentheses. Step 4 will be to multiply out completely and group the like terms on the right side. So multiply right side and combine like terms. Now, you might not have I guess I should really say group the like terms, not combine the like terms, because you won't ever have any like terms because of these A's and B's, right? You might have a bunch of x squareds, but no way of really combining them. But what you can do is, after you group them together, is you can factor out the common x squareds, x's, or whatever else is common. And then what you'll do is you will equate both sides of the equal sign, the coefficients. Equate coefficients, both sides. So what that means is, if I have 4x squared plus 2x plus 1 equals a plus b x squared plus a minus cx plus c. This is how I do that. The x squared coefficient is 4 here and a plus b there. So what that would mean is that if the equal sign has any validity to it, a plus b must equal 4. And if I look over here, 2 and a minus c must equal each other. And then finally, if I look here, c equals 1. Oops. And then you can back substitute, plug in your 1 right there. A minus 1 equals 2, so a equals 3. And then if a equals 3, 3 plus b equals 4, b equals 1. And what you could do there is you could go back and plug in what the a, b's, and c's are, and then end up with 3 new integrals. So it should be easier than your original problem. Okay? And what we're going to do is we're going to use this partial fractions technique as a last resort. So if you're able to try other types of integration first, please do so. But if it doesn't work out and you notice that the denominator can be factored, go ahead and factor that denominator as much as possible, and then apply one of the scenarios to decompose it. That's pretty much it for the concept video. I'm going to be applying that concept to do this integral on the first example video. So make sure you please check that out. Again, the first step in this one is what? Good. Factor that denominator so you can figure out which one of the scenarios it's going to be. In this case, it looks like it's a combination of the linear product and the quadratic one. All right. So I hope this has clarified the concept of partial fractions for integration. Make sure you check out the example video where I take this example and I take this integral as it sits, not doable, and use partial fractions to decompose it and make it into a much easier integral. I hope things have been clarified a little bit. Thank you and have a nice day.